Imagine a beach with billions of grains of sand. That's a lot, right? Now imagine that each grain of sand represents an entire galaxy. That's how many galaxies scientists estimate exist in the observable universe. It's a mind-boggling thought, and it highlights just how incredibly vast our universe truly is. To truly grasp the scale, we need to understand our place within it. Our planet, Earth, is just a tiny speck orbiting an average star we call the Sun. Our Sun, along with billions of other stars, forms a gigantic, swirling collection of stars, gas, and dust known as the Milky Way galaxy. But the Milky Way is just one of billions upon billions of galaxies scattered throughout the universe. Each of these galaxies contains billions, even trillions of stars, many of which likely have their own planetary systems. The sheer number of stars and planets out there is almost impossible to comprehend. The Milky Way galaxy, our cosmic home, is a barred spiral galaxy with a diameter of about 100,000 light-years. That means it would take light, traveling at an incredible speed of 186,282 miles per second, 100,000 years to cross from one end of our galaxy to the other. Within the Milky Way, our solar system resides in a relatively quiet spiral arm, far from the bustling galactic center. Our closest galactic neighbor is the Andromeda Galaxy, another spiral galaxy about 2.5 million light-years away. Andromeda and the Milky Way are the two largest members of the Local Group, a collection of over 50 galaxies gravitationally bound together. Beyond the Local Group lie countless other galaxies, forming vast clusters and superclusters, the largest known structures in the universe. These clusters are connected by filaments of dark matter, forming a cosmic web that stretches across the observable universe. To measure the vast distances between stars and galaxies, astronomers use a unit called a light year. A light year is the distance that light travels in 1 year. It's an enormous distance, equivalent to about 5.88 trillion miles. For example, the nearest star to our Sun, Proxima Centauri, is about 4.24 light-years away. This means that the light we see from Proxima Centauri today actually left the star 4.24 years ago. When we look at distant objects in space, we're essentially looking back in time. The most distant objects we can see with our telescopes are billions of light-years away. The light from these objects has been traveling through space for billions of years, reaching us only now. This means we're seeing these objects as they were billions of years ago, shortly after the universe began. Section 4. Putting the universe into perspective. To put the scale of the observable universe into perspective, imagine shrinking the Sun down to the size of a grapefruit. On this scale, Earth would be a tiny dot about 5 feet away. The nearest star, Proxima Centauri, would be another grapefruit located about 2,500 miles away. Our entire galaxy, the Milky Way, would be a vast collection of grapefruits spanning a distance of about 60 million miles. The Andromeda Galaxy, our nearest galactic neighbor, would be another enormous collection of grapefruits located about 15 billion miles away. The observable universe, containing billions upon billions of galaxies, would extend for trillions upon trillions of miles in every direction. It's a scale so immense that it's almost impossible to comprehend. Section 5. The ever-expanding frontier. One of the most fascinating discoveries in astronomy is that the universe is not static. It's constantly expanding, with galaxies moving away from each other like dots on an inflating balloon. This expansion was first observed by astronomer Edwin Hubble in the 1920s. Scientists believe that the universe began with a massive explosion called the Big Bang, which occurred about 13.8 billion years ago. Since then, the universe has been expanding and cooling, evolving from an extremely hot, dense state to the vast, complex cosmos we observe today. The expansion of the universe has profound implications for our understanding of space and time. It means that the universe has no center and no edge. It also means that the farther away a galaxy is from us, the faster it appears to be moving away from us. Section 6. A universe of endless possibilities. The vastness and complexity of the universe continue to inspire awe and wonder. As we learn more about our cosmic surroundings, we are confronted with even more questions than answers. How did the universe begin? What is it made of? Is there life beyond Earth? Exploring and understanding space is not just about satisfying our curiosity. It's about pushing the boundaries of human knowledge and seeking our place in the grand scheme of things. The more we discover about the universe, the more we realize how much more there is to learn. The universe is a vast and mysterious place, full of endless possibilities. By continuing to explore and study the cosmos, we can unlock its secrets and gain a deeper understanding of our place in the universe.